Very good morning to all of you. And today we will be going and we will be learning about the new topic that we will be having. So please let me know that voice is clear and video is clear. So based on that, we will be going and we will be starting with our session. So please let me know that voice is clear and video is clear so that we can go and we can start with our session. See, the today's topic we will be talking about is basically that we will be having. We have to, just find it out. Yes, we have to find it out, or first we will try to see that, just let me know that voice is clear and video is clear, so you do not have any problem with respect to that. So we can start with our session. See, the first thing that we people have to understand is basically what are the syllabus. So first we will be discussing about a little bit of syllabus and then the questions that will be related to that. See, this is basically the reverse engineering that the gate Wallah has started to all of you, so that you people can understand about the reverse engineering. See, what is a normal way of learning is basically first you are trying to understand the concept, and after that you will be trying to go and you will be trying to focus on, you will be trying to solve the questions. So first you will have a concept and then you will be having a question. But today what we will be doing is basically it will be a little bit different. We will be discussing the question and then we will be discussing the concept. So that is the thing that we just have to understand. So here we will be having the first questions that we will try to understand with respect to this. So this is basically the first question. So can you solve these questions related to that? Please let me know that voice is clear and video is clear. So once these questions we will be having, we can easily try to solve with respect to that. Okay, so here this is the first question that we people can go and we people can try to understand about it. Okay, this question is basically related to what? This question is basically related to the logic, and we will try to go and we will try to solve with the help of that. So for example, here we will be having P of x, Q of x and R of x denotes the following open statement. So P of x is basically an open statement that will be related to x square minus 8x plus 15, it is equals to 0. And Q of x, where x is basically representing odd, and R of x is basically representing where x is greater than 0. That means it is saying that here you will be getting all the elements, positive integers, you will be getting it. So now you will be having a first question. So basically this is A, B and C. So you have to find it out which one is going to be, which one is going to be true and which is going to be false. This is this question. So what we have to understand, this is a, you can say that a revision through a question. So first we will be trying to understand about a question and then we will be trying to do the revision. See, here we will be having the first question. So how to solve this type of question? So as our main intention, we will be having a question, and from a question we will try to understand the concept. So let me, we will also be discussing the concept. First we will try to understand the questions. See, as we know that, yes, good morning Tanuj, good morning Prashant. So the first thing that we people have to understand is basically the differences between these two. So, we will be trying to understand each and everything. Yes, good morning Nutan. See, what is our main intention is basically first we will try to understand. See, we will be having this logic. Into this logic, you will be having a different type of questions. So it is basically divided into two topics. One is basically called as the propositional logic, and then here we will be having the predicate logic. So in predicate logic, we will be having 2 or 3 different topics, and one of the topic is basically this. So how to solve this type of questions, that is nothing but our concern. So what you people can try to do, whenever you will have a certain questions like this, what you will do, first you will try to draw the box diagram of this. So first we have to draw the box diagram. So how we can draw the box diagram? See, whenever you will have, for example, suppose if you will have a statement like this. So I will try to clear it, see how you people can solve it. Suppose if you will have a statement like this, P of, for all of x, P of x and Q of x, and let's consider your domain, it is consisting of element 1, 2 and 3. Now what you people have to do is basically you have to draw the box method, and based on that we will try to understand. Now see, this x will go and will take element number 1 and it will try to substitute into this. So it will become your P of 1 and here it will become Q of 1. Now do not do that mistake. Don't put 1 over here and 2 over here. No, it will be taking one element at the same point of time. So here this x will take an element 1 and then it will try to substitute here P of 1 and Q of 1. Now this x will take an element 2. So after that, what it will be signifies? It will be signifies as an AND condition. So here we will be having the AND condition, and then after that, this x will be taking 2 elements. So it will become your P of 2, and here it will become your Q of 2. In the same way, and then the last one you will be getting is basically this one will become P of 3, and here it will become Q of 3. So this is the way of behavior. These things will be behaving like this. P of 1 and Q of 1, P of 2 and Q of 2, and P of 3 and Q of 3. So in that manner we will try to understand. Now, what you people have to understand ki whenever you will be having inside, you will be having the AND condition, and then you will be having there exists inside, you will be having the OR condition. So these things you people have to focus on little bit. Whenever you will have a for all of x kind of conditions, for all of x, when it is going to be true, it is going to be true when each and every element is going to be true. So instead of focusing on proving this statement, try to focus on disproving the statement. When you will try to disprove this statement, it will be very easy with respect to for all of x. So in for all of x, try to disprove a thing. See, when you will, why I am telling you like that, when you will have a for all of x condition, when you will try to go for a disproving thing, then you will need one counter example, okay, and then you can disprove it, because this is going to be true. So how many times you will check? Suppose if you will have 100 number of elements, so you have to check for first element, second element, third element, fourth element, and then you have to go for the 100th of element. So instead of proving for the large amount of element, try to disprove it. Matlab you have to put such a value so that it will be saying the false. With respect to this, try to go and try to put an element where it will be saying that it will be for proving thing. So whenever you will have for all of x, try to disprove it, try to make it as false. Whenever you will have a there exists of x, try to make that as a true. Now let's take the first example and we will try to understand what I am trying to tell you over here. First, what is our integer or what is our domain? Domain is basically a set of integers. So here we will be getting a large amount of elements into that. Now let's take the first element. So here we will be having for all of x, and then this is negation of q of x, and then that will be implying negation of p of x. Okay, now one thing that you people can do, you can take a contrapositive of this. So when you will take a contrapositive of this, what you will get? You will be getting is basically p of x, and then that will be implying q of x. Now here you will be getting a box diagram like this. So this one will become implication and then here you will be having this implication. Now if one of the box will give me answer as a false, then the whole things will become a false. For example, suppose you will be having a large amount of boxes like this. When you will have a large amount of boxes like this, instead of proving it, try to disprove it. So that is nothing but our concern. So what we can try to do it, when this one will become a false. So first thing that you people have to understand, when it will become a false. It will become a false when one of the boxes will give me a false. So still I cannot understand. Let me try to show it with the help of this representations. See, you will be having the large amount of elements. So here you will get one box, and then you will be getting second box, and then you will be getting a third box. So what is inside the box? Inside you will be having the implications, and what is outside the box? Outside you will be having the AND condition. Now if one of the box will be saying false, suppose if it will say the false, then this false will see this AND condition, and it does not care what these two boxes will be saying, then the whole statement it will become what? The whole statement it will become a false. That is nothing but our concern. In the same way, we will be having this. So first we will try to, instead of proving it, try to disprove it. When the p of x will become true, p of x will become a true when x square minus 8x plus 15. So if you try to solve it, the values you will be getting is basically 5 and 3. Am I right? Now try to take the values and try to put it. So suppose if I will try to put p of 5 here, then what is q of x? Q of x is saying that x is going to be odd. Now here it will become what? Q of 3. Now second statement that you can take is basically you can try to take p of 3, and then here you will be having the q of 3. Now can we say that it is going to be false at any point of cases? Can we say that it is going to be false for any type of cases? Now when the first one will become a true, then as soon as the first one will become a true, when the first one will become a true, first one will become a true with respect to 5 and with respect to 3. So when the first one will become a true with respect to 5, with respect to 3, then what will happen? Can we say that if any condition, see what is the meaning of it? It says that if anything is satisfying p of x, then 100% it will become the odd number, because q of x is saying that it is an odd number. So if anything is satisfying p of x, 100% it will become the odd number. So here what are the elements which are satisfying 5 and what are the elements which are satisfying for p of x? For p of x it is satisfying 5 and 3. So when 5 is satisfying for p of x, then it will become odd number, which is already true. 3 is satisfying for p of x, then again it is an odd number, which is also going to be true. So can we say that if any element that will be satisfying with respect to p of x, then 100% it will be satisfying for q of x. So in that manner we can say that any element which will be true for this will always become a true for that. So can we say that this can be a false? No, it cannot be a false at any point of time. Why it cannot be a false at any point of time? Because you will never get any boxes like that. See here, in order to make this as false, we should get a box like this where true will implies false. But we will never get this kind of conditions. Why? Because as soon as the first one will become a true, then the second one will automatically be true. How? Just read it. If anything is satisfying P of x, then it will become a odd number, because Q of x is saying that it is an odd number. So if anything is satisfying P of x, Q of x will become odd number. So what are the elements which are satisfying for P of x? 3, odd number, 5, odd number. So you will never get this kind of cases. Sir, I am having one doubt. Sir, you are just taking 2 elements. What will happen if I will take any other element? See, if you will take any other element, then what will happen? P of x, this condition will become a false. Suppose if you will take 2, then what will happen? It will become false, because 2 is not satisfying for P of x. So false will imply anything will become true. False will imply anything will become true. So can we say that here we are getting the answer as a true for the first one? Can you tell me that? Right? So can we say that the first statement it will become a true? So in that manner we can try to go and we can try to use. See, this is totally based on our analogy. This is totally based on how we people can try to understand with respect to this. So this is one of the important topic that you people can try to understand. Clear this point? Please reply. Okay, so in that manner we can try to find it out with respect to that. So always try to go, instead of proving it, try to disprove it. So we can say that the option A, that is nothing but going to be true. Okay, now let's go for the second one. And what the second one says, that here you will be having there exists of x, and then this one will become P of x, and then it will implies that here this is Q of x and R of x. Now you just try to draw the box diagram of that. When you will try to draw the box diagram of that, here you will get one box like that, and then after that what you will be getting? You will be getting a boxes like that. Now instead of disproving it, instead of disproving the second one, try to prove it. See, here you will have a there exists, so that means you will get OR condition here, and then you will get implications like this, and then in between you will have a AND condition. So here you will have a implications, and then in between you will be having the AND condition. These things I am writing based on that. Now, because this is there exists of x, if it is there exists of x, in outside of the box you will get OR condition, inside first you will get an implication, after that you will get an AND condition. Inside you will get an implication, and then you will get AND condition. And this is totally based on the second one, P of x, it is implying P of x and R of x. Now, first you will try to understand about the P of x. P of x, when it will become a true? It will become a true for 5 and 3. Suppose instead of putting 5 and 3, what will happen if I will put 2? What will happen if I will put 1? What will happen if I will put 4? Suppose, let's say if you try to put the values as a P of 2. Now, if you will take the value x is equals to 2, then here it will become P of 2, and then it will imply something. Now, as we know that if for P of 2, this P of x, it will show me false. Why it will show me false? Because P of x, it is only true for 5 and 3. So suppose if you try to put P of x as a 5 and 3, it will only be showing me true as an answer only for 5 and 3, not other than 5 and 3. But I have taken x it is equals to 2. First type of doubt that you people can ask me, sir, why you are taking 2? Because your domain, it is a set of integers. They have already specified. Universe is basically set of all the integers. So your domain is basically integers. You can, instead of taking 3 and 5, you can take any particular element. You can take 0, you can take 1, you can take many minus integers, you can take positive integers, you can take any particular thing. Now, if you will put x equals to 2. So, sir, are you trying to say that x can take any type of value? Yes, x can take any type of value. X can take 2, x can take 3, x can take 4, x can take 5. Now, if you will put x equals to 2, then this will P of 2. For P of 2, what it shows? It shows false. Now, false will imply anything will become a true. So, false implies anything outside of the box, you will be having answer as a true. Now, this is true. This true will see this OR. So, it does not matter what the other boxes you are writing, then the whole statement, it will become a true. So, we can say that for the option B also, it is also going to be true. Please reply, you have understood. Okay, So in that manner we have to solve. So like this, you people can solve any number of questions which is totally based on the this type of boxes method. And personally, me and my all the students, they used to call this as the box method. So with the help of this box method, we can easily try to solve the questions which is related to that. Clear, everyone? So in that manner, we will be having the box method and we will easily try to understand with respect to this. So this is one of the important topic that you people can easily understand with respect to this. Now, see, our main intention, the whole intention of this particular class is division through a question. Now, whenever you will have this type of box method, with the help of this type of box method, what you people can go and try to use it, you people can try to solve this type of questions as much as possible for all of x, p of x and q of x, and then this can implies for all of x, p of x, okay, and for all of x, q of x. Okay, so basically this type of equations you can try to use with the help of a box method. So that will be very applicable, that will be very easy when you will try to put the box methods with respect to that. So this is very much important, and in that manner you people can try to solve it. So that method will help you not just to solve that particular question, but that method is also very helpful in order to solve this type of question. You may have seen that this type of question has been came into GATE examinations. For example, p of x, that will imply a, and then try to prove that for all of x, p of x, and then this is implying a. So here also you can have a box method. So in this way, this a is called as a free variable. You can put the values of a as a true one time, and you can put a as a false as a one time, and then you can try to evaluate with the help of box method. So this is again, that is with the link with that the previous questions. So I hope this has been clear to each and every person. What about the second one? Here you will be having for all of x, this is p of x or q of x. How we can make this statement as a true? Okay, how we can make this statement as a true? See, q of x, see, as I told you, here we will be focusing on a true statement, while here we will be focusing on the false statement. Now for the last one, if you try to follow, this is basically implication, and then here you will have a or condition. So suppose if I will make the first statement as a true and second statement as a false, I will be getting answer as a false. Outside of the box, what you will be having? Outside of the box, you will be having this and condition. Now false will see this and condition, then the whole statement it will become false. Now you just try to focus how we can make this statement like that. When the r of x will become false, r of x will become a false when it will become a negative element. So suppose if I'll put -2 or something like that, because this is a negative element. Now, as you can see that, or it's try to put -1 element over here. So if we'll put -1, then r of x will become false. Why? Because the value of x is greater than 0. When the value of x is greater than 0, so for x it is equals to -1, r of x will become a false. But q of x will become a true. So here you will be having, see, this q of x, it will become a true. Because q of x says that x should be odd number. So yes, I am getting my odd number. My odd number is -1. So q of x will become a true. So this whole box will be showing answer as a true, but the right side will become a false. So true implies false will become false. Outside of this box will see false, will see this and condition, then the whole statement will become a false. So in that manner, we can try to say that the option C you will be getting is basically false. Understood, everyone? So we can use this type of method, and then it is very helpful to solve this type of questions related to that. So it will be very beneficial when you will try to use this particular method, a kind of thing like that. Okay, now let's move to the next question. Okay, so let's consider it first. We have to find it out the GLB and LUB with respect to this question. So here we will be having the first statement. So can you try to give me the answers which is related to that? So first, the GLB of B comma C. So where is B and C? So here you will be having B, and then here you will be having C. Whenever you will be having this GLB, how to read it? Reading is very important. The way you will be reading, the way you will be getting your answers. Greatest lower bound. Okay? And then next one is basically called as the LUB. So least upper bound, greatest lower bound. I always tell to all my students, try to read it in 2 or 3 terms. For example, least upper bound, greatest lower bound, least upper bound, greatest lower bound. In that manner you try to read it. So first we will be having the first one, which is nothing but GLB. So I will try to read this GLB as a 2 parts, greatest lower bound. So here you will have a B and C, and what is the lower bound of it? Lower bound of this, if you try to see that, here you will be getting A, because that is the lower bound and that is also the greatest one. So can I say that GLB of B comma C, here you will be getting answer as A? Yes or no? So in that manner, you people can try to understand with respect to this. So GLB of B comma C, you will be getting answer as the A. So lower bound, first you will try to understand the lower bound, and then after that you will try to find it out about the greatest one. Okay, so I think everybody knows about what is the greatest lower bound, what is the least upper bound. So you have to focus on the lower bound, lower bound, lower bound, lower bound, lower bound, and then the greatest one. Upper bound, upper bound, upper bound, upper bound, and then the least one. You also try to imagine like this. So for example, greatest lower bound. So lower bound, lower bound, lower bound, lower bound, and then this element is basically the greatest lower bound. So greatest among all the lower bounds, and it should maintain the relation also. So lower bound, lower bound, lower bound, lower bound, and then the greatest among that. And then after next one, you will be having the least upper bound. So least upper bound, you will be having upper bound, upper bound, upper bound, upper bound, and then this element is basically called as the least upper bound. So that will be very helpful. This is just a visualization, not the correct one, but this is just to visualize what how the GLB will be representation, or what will be the representation of LUB. So it will be very beneficial when you will be trying to find it out with respect to the GLB, and you will be trying to find it out with respect to the LUB. Okay, so that has been clear. Now let's take an example for B comma W. So how we can try to find it out about B comma W? So this is basically B, and then this is basically W. So for these two relations, you have to find it out the greatest lower bound. So first you will focus on lower bound. I always tell to all my students, you try to read these things in two parts: lower bound and then the greatest lower bound, upper bound then the least upper bound. So here you will have a greatest lower bound. So first lower bound and then the greatest one. Now as you can see that this is W, this is B. Now first you will try to understand, you have to find it out the lower bound of B comma W. So this till here, where it is matching, so it is matching over here. See, you cannot take C, because C is lower bound of W, but there is no relations between C and B. So you have to maintain an element. If you want the logical explanation about it, so in terms of a lower bound, you have to write an element which should be related to B and W both. Suppose if you are writing C here, see, C is related to W, for this statement it will become a true. But can we say that C is also related to B? No, C is not related to B. So we cannot write C over here. So you have to write an element, okay? You have to write an element where it should be lower bound of both the things, okay? So can we say that A is also answer with respect to that? So here also you will be getting answer with respect to A. Okay, can you tell me about C, D, E, F and G fast? Then I will try to explain you. Okay, just do it. Okay, now let's talk about the GLB of E comma X. If you want to find it out GLB of E comma X, so this is basically your E, and then where is X? So this is your X. Now where these points are meeting, so here we can try to see that the एक lower bound, one lower bound is basically with respect to what? See, C is lower bound of X and E both. Can we say that W? No, W is a lower bound of X, but there is no relations between W and E. So you have to find it out. C is basically one lower bound. So here if I will try to find it out GLB of E comma X. So here first we will try to find it out the lower bound. So once you will try to find it out about the lower bound, so C is also one lower bound and A is also a lower bound. But which one is the greatest one? So this one will become the GLB. This is the same expression when I was trying to explain you with the like that. You will have a lower bound, lower bound, lower bound, and then this one will become the greatest lower bound. So here we will be having the greatest lower bound. So we can try to say that E and X, so which is basically the point which we are saying that. Okay, now this C is also related to E, and then this C is also related to X. So can we say that C is the right answer with respect to this? So for option C, we will be getting what? We will be getting C. Understood? Yes or no? So in that manner, we can try to find it out with respect to what? With respect to this statement. Now let's talk about the D, and we will try to understand with respect to D. What the D says that ki upper bound of C and B. So here this is C and then this is B. What are the upper bounds? Upper bounds, if you try to see that, the upper bounds, first upper bound you will get E, after that you will get Y, and then after that you will get Z. So upper bound, C and B, both upper bound, first you will get E, and then you will get Y, and then you will get Z. You just try to focus, E, Y and Z. And which one is the least one? So here we can say that this one is the least one. So this one will become our LUB. So in that manner, we can try to say that the answer with respect to LUB of C comma B is basically E. So in that manner, you can try to say that. Okay. While E, F and G, you take it as a homework because we have already discussed the same type of things. So there is no point of, related to that. Okay. So in that manner, we can try to find it out. Understood everyone? So here we will be having this type of questions, and then that will be helpful with respect to GLB. So by solving these questions, we got the idea about GLB and we got the idea about LUB. Or if you're watching this video later, you just try to, calculate the LUB of E, F and G and then write it in the comment box. Okay, what should be the LUB of E, what should be the LU of F and what should be the LU of G. So in that manner, we can try to find it out with respect to this particular concept. So here we will be having this. We have already calculated with respect to this. See, our main intention is to understand about the LUB and is to understand about the GLB. So how you people, I have already given you the visualizations with respect to that. GLB is basically how to read it. First thing, whenever you will have a questions related to GLB or whenever you will have a questions related to the LUB, what you people will be doing, try to divide these things into two parts. LUB will be there, GLB will be there. The least upper bound and then the greatest lower bound. Least upper bound, greatest lower bound. Reading is very important. After, as soon as you will be having the concept of a reading, after that what you will do, you will try to understand this type of representations here. This one is upper bound, upper bound, upper bound, upper bound, and then this one is the least upper bound. So this is the imagination point that you people can try to understand. Okay, so I hope this is very clear to each and everyone. Okay, we'll move to the next question here. Okay, now can you try to understand? Okay, so here we will be having this representation ki GLB is basically represented like this and then LUB is also represented like this. Or another way of understanding, this is representing as an intersection, this is representing as a union. So which of the following is basically true with respect to this particular statement? So here we will be having this associative and then this is going to be, check whether this one is satisfying the associative or not. With respect to, we are having a two expressions and then we will try to find it out with respect to that. Do not get confusion. See, whenever in lattice, whenever you will have a word as a poset or whenever you will have a word as a lattice and whenever this has been given, so try to take that as a LUB. Do not take that as a OR condition or AND condition. Or whenever you will have something like that, you will try to take that as a GLB. So how you people can try to understand? Obviously it is having some meaning, obviously it is having some representation, but I have already given with respect to that. Or you can also try to understand this one is representing the dot and then this one is representing plus sign. Okay, so with the help of that, can you try to find it out which expression it is going to be true and which expression it is going to be false? So that is also very beneficial. Whenever you will have this particular cases, it will be trying to say that it is LUB. Whenever you will have this type of cases, it will be trying to say that it is going to be represented as a GLB. So with the help of that, you can easily try to understand which is going to be true, which is going to be false. Let's try to take one example over here. So here this one is saying X OR and then Y and Z. Okay, and then here it is trying to say that this is not associative law. This is basically the the distributive or different operator they have used. Okay, and then this is X or Y and then here you will be having Z. This is not distributive law because operators are different. Okay, first we will try to understand with respect to that. So see what it represents. The AND is representing the GLB. So first we will try to find it out what is the GLB of Y comma Z. So here we will have Y and then this is Z. Lower bound, greatest lower bound. So here you will get O. Okay, so O and then after that you will have X. So what is the meaning of it? It means LUB of, because this one X comma O. So if we'll try to find it out, x comma o, which is the LUB, upper bound, least upper bound. So this one is basically the upper bound, this is also the upper bound, but this one is the least upper bound. So you will get answer with respect to this, you will get answer as a x. Am I right? Right? So in that manner we can try to find it out with respect to this. So okay, now let's try to find it out x or y. So here you will be getting LUB of x comma y. So x and y, what is the LUB? Upper bound, this is I and then here and z. Now GLB of I and z. So here I and z, lower bound, greatest lower bound. So z is also lower bound and that is also greatest lower bound. So here what you will get? You will get z. So can we say that the first statement it is true? Can we say that the first statement it is true? See, the whole game it is related to the GLB, the whole game it is related to the LUB. Once you will try to understand about the LUB, once you will try to understand about the GLB, then you can easily try to get your answers. So in that manner, we can try to say that our first statement it is basically false. So that's how you will be getting LUB, that's how you will be getting the GLB. Okay. In that manner, Prashant, this is the way of solving a question. Okay. So once I think you people have understood the first statement, it is basically false. Now let's see the second statement, and then second statement we will try to find it out. Do not forget that here we will be having the representation such that whenever you try to see the GLB, you will be having this representation, and then LUB you will be having this particular representation. Now let's see the second statement. Okay? Second statement it says that here we will be having this, and what it says that? It says that x or and then y and z. So first you will try to find it out the GLB of y comma z. So what is the GLB of y comma z? GLB of y comma z is, let me take this as A, okay, and let me take this as P, okay. So it will be very easy instead of writing O and I. Okay, so here GLB of y comma z you will get A. So here x or A. X or A means it should be representing the LUB of x comma A. So LUB of x comma A, x and A, upper bound, least upper bound. You will get answer as the x. So here in the left side we are getting answer as the x. Let's see the right side. So and here you will get x or z. So x or y. So first LUB of x comma y and here LUB of x comma z. So LUB of x comma y, x, y, least upper bound, least upper bound. So x, y, upper bound you will get P here. LUB, x comma z, x and z. Upper bound is again you will be getting P. So P and P you will be getting answer as a P, which is not equals to this. So can we say that which statement it is true? Both S1 and S2 are basically false. Very good. Clear everyone? So in that manner we can try to find it out the questions which has been related to that. Clear? So this is nothing but our case, and with the help of that we can easily try to get our answers. So you don't have to do anything. You have to, how many concepts we will require to solve this type of question? You should know about GLB, you should know about LUB, you should know this representation, you should know this representation, when the GLB will be there, when the LUB will be there. Okay, so that will be very beneficial when you will try to find it out with respect to this. Clear? So our answer will become D. In that manner we can try to find it out which one is going to be the LUB, which one is going to be the GLB. Okay, which of the following is not true? That means not true in the sense it is which of the following is basically false. So here we will be having the matching number of a complete graph. It is basically this function, okay. It is basically the ceiling function, they are trying to say that. Okay, here we will be having the ceiling function. So what should be the matching? There is no need to remember join or meet cases. What you people can try to do it, you have to calculate. Okay, you have to calculate. I always, instead of, as I told you, how you are reading it, that matters a lot in join and meet. GLB and LUB. So it is totally based on the reading. Lower bound, greatest lower bound, upper bound, upper bound, upper bound, least upper bound. So it is totally, okay? See, as I told you, it is totally based on how you people are reading. So reading is very, very important. So greatest lower bound, I know that join and meet sometimes are basically confusing to the students. Basically, it says the same thing in literature, okay? But what is my point? why I personally tell all the students to read as a GLB or LUB. I know that at this time you cannot change it, but GLB or LUB, greatest lower bound, least upper bound, greatest lower bound, least upper bound, greatest lower bound, lower bound, lower bound, greatest one, upper bound, upper bound, upper bound, least one. So that's how you people can try to understand. Okay, anyhow, we will have these options. So which of the following statement is going to be false? They are saying that which is not true, so which is going to be false. Okay, so in that manner we can try to understand. So matching number of a complete graph, what it says that it is floor of n by 2. Okay, so what should be the floor of n by 2? Sorry, ceiling of n by 2. So in that manner, how you people can approach this question? So by drawing the graph, that is the only thing that you people can do it. So I will help you into one or two, and then you will try to cover into that. So first of all, how to solve this question? In order to solve this question, you should know what is the matching number of a graph. So first you will try to find it out what is the matching. Matching is basically a set of non-adjacent edges. Matching set, it is equals to set of non-adjacent edges. So for example, let's take K3. Suppose if I will take K3, then you try to remember what is the definition of a matching set. So here I am writing the definition of a matching set. It is a set of non-adjacent edges. Set of non-adjacent set, okay, set of non-adjacent edges. So that is nothing but the one important concern that we people have to understand. It is a set of non-adjacent edges. For example, suppose if I will be taking this particular edge, then I cannot take this edge, I cannot take this edge. So with respect to K3, I am getting my matching number as a 1. Okay. So here you will be getting, I think this is not floor, this is not ceiling, this is floor function. Okay. This is floor function. Okay. Okay. So for K3 you will be getting as a 1. Now let's talk about the K4. So suppose if I will be taking a K4, so what should be the matching number of that? So here with respect to the K4, if I will try to take this particular example, then I cannot take this edge, I cannot take this edge, I cannot take this edge. Then I can take this edge. With respect to the K4, you will be getting matching number as a 2. Now what will happen? I just now understood that for 4 I am getting matching number as a 2. So obviously it is dividing. So here I got the idea that basically it is n by 2. But with respect to 3, I am getting my answer as a 1. So n by 2 with respect to 3. So 3 by 2, but this is 3 by 2 according to the formula. But what is my right answer? Right answer I am getting as a 1. So 3 by 2, 1.5. So I have to take a floor function. So when I will be taking a floor function, I will get my answer as a 1. You understood how I have concluded this? So this is the same situation will also happen to you in your examination. Sometimes you won't be getting a direct formula. So at that point of time, you can take a multiple examples and you can come up with your own analysis. So here I have done the analysis. I have not remembered this formula. I have done the analysis. Based on the analysis, I have trying to find it out. What it is trying to say, for K3, I was getting answer as a 1. So I convinced myself ki okay, 3 for 3, I am getting answer as a 1. For K4, I am getting answer as a 2. So now I will be very, happy. For K4, I am getting answer as a 2. That means somewhere it is basically, okay, some 4. Okay. So basically what I am trying to tell you ki 4 hai to 2 hai. So for 4 you are getting 2. Somewhere it is dividing. So with respect to 3, it is dividing, yes. So I have to take a floor function of that and I am getting answer as a 1. So this statement, first statement, it is true. So this is basically your floor function. Okay, these all are floor function. So can you try to calculate for Cn and can you try to calculate for Wn? So in that manner we can try to find it out. Clear? Please calculate and tell me. Okay, so here we will be having the matching number of a Cn, matching number of a Wn. So you can also take an example with respect to that. So this is also true. So again, it is also will become a floor function of what? N by 2. Okay, this is also a floor function of n by 2. This is also floor function of n by 2. So for this statement, it is also true. For this statement, it is also true. So we can say that the matching number of a complete graph, it is equals to matching number of a wheel graph and matching number of a Cn graph. This all are basically floor of n by 2, and then these statements are true. But what about the last statement? Last statement, what it says that? It says that the matching number of a k, m, comma, n. So what we can try to say that with respect to this, you take an example of a k to 4. Suppose if you take an example of k to 4, what you will get? The matching number of a k to 4, here you will get answer as a 2. But the formula says that it is 2 plus 4, 6, 6 by 2, you are getting 3. If you will put into this formula, you will get answer as a 3. But in reality, the matching number of k to 4, it will become 2. So that's why we can say that the matching number of a complete bipartite graph, it should be the minimum of m comma n. Okay, so that is why the last statement, it will become a false, while this statement, it is true. So in that manner, we can try to find it out. Understood everyone? Any doubt to anyone? Please let me know that. Okay, so this will be very helpful. Okay, we'll move to the next question. Okay, now can you try to solve this question? This question is related to the combinatorics and it is very easy, and you people can easily try to understand the question. First, you will try to understand what this question is saying, that this is related to what? This is related to the combinatorics. Okay, see, let me make it very helpful to you. So here you will have, okay, do not read it. Okay, just try to see the the graph. In this graph, what it is trying to say that actually you will have a one particular point here, okay, and then the other particular point will be here. So suppose if I will take you, first you will try to understand the question, Prashant, and everyone, then I will try to give you the concept regarding it. Actually, suppose, let's consider there is one playground. In that playground, you will have some type of representation like that, okay, and then you will have some axis, x-axis and y-axis. Now I will take you and I will put it at this point, which is representing as what? Which is representing as a 2, 1. So I will put it as, this is like a game. I will take you and I will put it at that point of time, at that particular axis. Now I will tell you this is a game. Right now you are here and you have to go to 7, 4. Okay. Okay. So you have to go to 7, 4. Now what is the condition? The condition says that you can either take a right or you can take up. So only two paths you can try to select it. Okay. Either you can move right or you can move up. So this is two examples that that has been given into that. So let's try to discuss about one example. So this is basically right, this is up, this is right, right, up, right, right, up. Okay. So in that manner we can try to understand this you have taken right, this is up, this is right, this is right, this is up, this is right, this is right, this is up. So this is one possibility. The other possibilities are like this. See, this is up, right, right, right. This is right, right, right. This is up, up. This is right, and this is right. So first we will try to understand what are the representations you are getting. So actually in this question you have to find it out how many ways you can move from 2, 1 to 7, 4. Okay. This is the question. So how many number of paths, how many ways you can go from 2, 1 to 7, 4. This is the question. First, I hope you understood the game, the rule of a game. Rule of a game, you are right now, you are at 2, 1, you have to go to 7, 4, and what are the conditions are applied? Either you can take up or you can take a right. So how many ways you can go from one place to other place? This is one possibility, this is another possibility. These two examples which has been given right now. Now, you just write, say this is very beautiful question. First, let's try to see the first, what are the possibilities? So I have taken right and then I have taken up. I'm just writing what I have done here. This is right, this is right, this is up, this is right, this is right, this is up. This is the possibility. Now second possibility, this is up, this is right, this is right, this is right, up, up, right and right. If you will try to see that in this also I have taken 3 up and 5 rights. In this possibilities also, I have taken 3 up and 5 rights. So basically, my whole question will change. The whole questions will be like that. Whatever the path you will be choosing, you will get 3 ups and 5 rights. Because from 2 comma 1 to 7 comma 4, from 2 comma 1 to 7 comma 4. So if you try to understand 7 comma 4, so you will get 5 rights and you will get 3 ups. 7 minus 2, 5 rights, 4 minus 1, 3 ups. Okay. So from 2 comma 1 to 7 comma 4, you can take 3 ups and 5 rights. The combination of 3 ups and 5 rights. Now, this whole question changes to permutations with identical objects. You know, we are having a name, permutations with identical objects. Now, let's discuss that. If I will ask you, how many ways you can arrange this letter? Okay, how many ways you can arrange this letter? How many ways you can arrange this letter? So, permutations with identical object, what it says that ki n factorial divided by k1 factorial of one kind and then k2 factorial of another kind. This is the same example that you people can understand. How many ways you can write the databases? How many ways you can write the Mississippi? Okay, so in that manner, where the repetitions are allowed, permutations with identical objects. So if I will ask you the question, how many ways you can arrange this and how many ways you can arrange this? So you will be getting 8 factorial divided by 5 factorial and then into 3 factorial. This will become your answer. Understood? Please reply. This question was fabulous and you people have understood the concept which has been related to that. Please reply. Right? So in that manner, we can try to find it out with respect to how many ways you can go from one particular place to other particular place. So this is basically the concept that you people can try to understand. Okay. So how many ways you can go from one particular place to another particular place. So this is a very beautiful. This is one of my personally. I like this topic. I like this question. Okay. This is called as the permutations with identical objects. I hope you people know that what is the permutations with identical objects. Okay. The permutations with identical objects. It says that total factorial divided by the repetitions. Okay. Total factorials divided by the repetitions. In that manner, we can try to get it. I think everybody has understood. If you have understood, we'll move to the next questions that will be related to that. Okay, so here we will be having a question. How many non-negative integer solutions are there for the pair of equations x1 to x7, that is 37, where x1 plus x2 plus x3 it is fixed. Okay, this one is going to be fixed, which is nothing but 6, and then from here to here, what it should be? It should be 31. Can you give me the answer with respect to that? Actually, this whole question changes to like this. X1 plus x2 plus x3 it is equals to 6, where x4 plus x5 plus x6 plus x7 it is equals to 31. Because 6 has been distributed here, so it will become 31, where your xi is greater than or equal to 0. Okay, so this question we can try to solve with the help of combinations with repetition. So in this combinations with repetition, this is 6 and 2. So here you will get 8c2, and this is 31, 31, 33, 32, 33, 34, and then 34c, you will get 3. So we can say that our answer will become 8c2 into 34c3. Can we say like that? This Prashant, you just try to calculate from here to here how many. See, from here to here you require 3 ups and then 5 rights. This is simple concept. From here to here you require 5 rights and 3 ups. 5 rights, 3 ups. Any combination of that. In that manner I have done it. You understood this question? Can anyone tell me that you can try to solve these questions with combinations with repetitions? Do you know? Okay. Do you know the combinations with repetitions wale questions? You can try to solve with the help of this. First of all, you should know how you people can solve these questions with the help of combinations with repetition. Okay, you do not know about it, so let me try to tell you. I think you know what is the combinations with repetitions, right? For example, if I will say that how many ways, okay, suppose if I will say that how many ways we can distribute, okay, we can distribute, let me write it so that I can distribute 10 similar coins, okay, 10 similar coins among 3 children. among 3 children. Okay, suppose this is your question, 10 similar, how many ways you can distribute 10 similar coins among 3 children. So here this is first person, this is second person, this is third person, and one possibilities are you will have a 3 coin here, you will have a 4 coins here, and then you will have a 3 coin here. So this is the possibility. So how you people try to solve it? You try to solve it, you will have a 10 coins and then you will have a 3 children, then you will get 2 partitions. So what you people are saying that key coin, or you can say that key in that manner coin plus line combinations line. This is the formula. Okay, either you can take a similar coin, or you can take a similar chocolate, or you can take a ball. So coin plus line and then combination line. So how many coins you are having? 10. And then how many line you will have? You will have a 2 partitions, you will have a 2 line. So 10 plus 2 C2. So here you will get answer as a 12 C2. Okay. So 10 and then 2 lines, 12 C 2 lines. The same equation, this same equation you can also try to write down in that manner ki x1 plus x2 plus x3 it is equals to 10. So suppose if I will say that what should be the answer with respect to this, what should be the non-negative answer you will be getting it. So the first distribution, if I try to find it out, this is x1, it is related to 3, and then x2 it is related to 4, and then x3 it is related to 3. So this equation, this question is same as this question. So 10 and then you will get 2 partitions. Okay. So here you will have a 10 and then you will get 2 partitions. So that is why 12C2. The same equations you can try to connect with this. So whenever you will have this type of questions, you can try to understand with respect to this type of questions. Okay. So 12C2, 10 plus 2 C2. Now the same equations we will have. In this equation there is a little bit of difference. For example, first we will try to understand ki we are having one questions like that. See, right now suppose if I will say that ki right now you do not focus on that. Okay. Right now do not focus on that. Suppose if I will say that ki what should be the answer of this? What should be the answer of this? So plain answer you will say that ki you will have a 7 children and you will have a 37 different types of coins. So 37 and then 1, 2, 7 hai. So for 7 you will get 6 partitions. So 37 plus 6 and then C6. So this will become your answer. Okay, this is your basically answer. But let's try to say that the modified one. So here I have removed this. Now x1 plus x2 plus x3. If you directly try to solve this question, what you will get? You will get answer as the 8C2. 6 this and 2 partitions. So you will get the total partition is 8C2. But here if you try to see that this one is basically fixed. So for this 3 children you should get answer as a 6. But from here to here 37 minus 6 it should become 31. So with respect to x4, with respect to x5, this is x6 plus x7, it is equals to 31 because the 6 has been given to x1 plus x2 plus x3. Now this is 31 and then 1, this is 2, this is 3 partition. So 31 plus 3 and then C3. So here you will get 34 C3. So this is with the help of a product rule, we can try to write it like that. So here you will get 34 C3. Please reply that you people have understood this question. Okay, I think everybody has understood the Prashant, the Tanuj, the Anjali. Is there anyone who are watching? Please let me know that you have fully understood this particular question. Okay, this question is basically the this is one step advanced as compared to the previous question. Okay, so in that manner we can try to solve it. Okay, now here we are having the concept of what? This is basically the concept of generating function. So how we people can try to solve it? We have to find it out the coefficient of x raised to 15. So this is x raised to 2 plus x raised to 3 plus x raised to 4 and then it leads to 4 here. So you take x square common, you will get 4. This one will become 1 plus x square plus and then it is raised to 4. So here it will become x raised to 8 and then 1 upon 1 minus x and then raised to 4. So x raised to 8, 1 minus x minus 4. You need the coefficient of x raised to 15. So how much you will be withdrawing from here? So how much you will be withdrawing from here? That will become x raised to 7. So see, when the x raised to 8 will multiply with x raised to 7, it will give the concept of x raised to 15. So here from here you have to find it out what? You have to find it out the x raised to 7. So coefficient of x raised to 7 will become minus 4c7 minus x raised to 7, and this one will multiply with x raised to 8 and then it will give 15. So here how you people can solve it? Minus 4c7. This is called as the extended binomial coefficient, which can become minus nck and then minus 1 raised to k, and here n plus k minus 1, and then here we will get ck. So in that manner you can try to find it out, x raised to 8. So here you will get minus 1 raised to 7 and 4 plus 7 minus 1 and then c7 minus 1 raised to 7 and then x raised to 7. This and this gets positive answer. 4 plus 7, it will become 11 minus 1, 10, 10c7 or 10c7 or 10c3. Why 7? Because see, this x raised to 7, what is the coefficient of x raised to 15? I mean, we have to find it out, the coefficient of x raised to 15. This x raised to 8, when it will multiply with anything, when it will become 15. Matlab, you just try to understand. I'll write it here. X raised to 8 into x raised to 7, then it will become x raised to 15, right? Okay, understood? So you will get the answer as a 10c7 or 10c3. So in that manner we can try to find it out. Clear everyone? Please reply. Clear? So that's how we can get our answers which is related to that. Okay? Clear? Okay. So this is very useful question you people can have. Okay, this is a NAT type of questions and it is based on the pigeonhole principle. What should be the minimum size of subset from the set 1 to 9 must contain 2 elements whose sum is 10. Okay, you just try to understand these questions and try to solve with the help of pigeonhole principle. Okay? 19, no, it should be from this set. See, what actually this question is trying to say that, first you will try to understand what this question is trying to say. That the question says that you will have one set and that will be consisting of this type of element 1 to 9. So out of this you have to maintain one subset, and what should be the size of this subset shows that every time if you will add any 2 element, the answer will become 10. For example, see, 1 to 9 will be there. What you people can do, you cannot see this set. This set is basically black box. You take any 2 element. First, let's consider that some of you are giving me the answer as a 2. Suppose if some of you are giving me answer as a 2, such that sir, there is a subset of size 2 where the addition of that will always become a 10. No, I will take any 2 elements. So for example, if I will take an element 1, 2, but this is one possibility where it will not become the answer. So 1, 2, the subset answer will not become a 2. Then you people will be saying that sir, it will become a 3. So if you will go for a worst case scenario, so here 1, first I'll remove 1. This is a worst case scenario. I'll remove 1, I'll remove 2, I'll remove 3, I'll remove 4, and I'll remove 5. So 1, 2, 3, 4, 5. Till here, if you will add, are you getting the addition as a 9, addition as a 10? No, you are not getting addition as a 10. Now what are the elements are remaining? So 6, 7, 8 and 9. Now you will remove 6. Okay, then 6 plus 4 will become a 10. Now you will remove 7, 7 plus 3, 8 plus 2, 9 plus 1. So this is the worst case. So 5 till 5 elements, it will not take the guarantee. But till 6 element, if you will have a subset of size 6, 100% the addition of 2 elements will become 10. So that is why this is called as the, with the help of pigeonhole principle. So this is the worst case. If you will remove any new element, 100% it will be falling under one of the cases, and then addition will become a 10. Please reply that you have understood this question. Please let me know that you have understood the questions which we have discussed here. Okay. So it will be very okay, very good, Akshay. So that's how, with the help of pigeonhole principle. Okay, once again you want me to explain, no problem. See, first you will try to understand, even if you will not use, okay, even if you will not use the pigeonhole principle, with the help of common sense you people can try to understand. What you will try to see that there is this box, okay, this is basically a box, and inside there is 9 elements. Element number 1, element number 2, element number 3, element number 4. Out of this, you have to make one subset such that what should be the size of this subset when you will add any 2 element. When you will add any 2 element, the addition will become 10. Then you will say that, sir, the answer is 2. Then I will say that, okay, which one? 6 and 4. But you have given me the answer as a 6 and 4. Suppose if I will withdraw, I will get, so for example, 1, 2. The addition of 1, 2 is not 10. So answer 2 is wrong. Now you will say that, sir, answer 3, 1, 6, 4. So sir, the answer 100% now it is true, because if I have taken a element, I have taken a subset of size 3 where addition of 6 and 4 will become a 10. Then I will say that what will happen if I will remove 1, 2, 3. So this 3, even if you will add any 2 elements, 100% it will never become a, addition will become a 10. So in a worst case, if you will remove 1, 2, 3, 4 and 5. So till 5 elements, it does not take the guarantee. Till 5 element, it does not take the guarantee. But as soon as you will remove the 6th element, so what are the elements has been remained? 6, 7, 8 and 9. So if you will remove 6, you will get addition as a 10. How? So this, what you will, whatever you will put here, either you will put 6, either you will put 7, either you will put 8 or you will put 9. Whatever you will put it here, 100% the addition will become 10. So that's how the answer you are getting is basically 10. Clear, everyone? Please reply that you people have understood the concepts which has been related to this. Either you can understand with the help of normal one, or you can try to use with the help of the pigeonhole principle. Okay, so in that manner we can try to find it out how we people can try to solve the question. Okay, clear, everyone? Okay, so here we will have a logic question. So we can also try to find it out which one is going to be valid and which one is not going to be valid. Let's consider this is statement number 1 and then this is statement number 2. Based on that, we can try to find it out. I hope you people know how to solve this type of questions. Okay, so first you will try to tell me that which statements are valid. Statement number 1, statement number 2. Which is going to be valid, and you know that how to solve this type of questions. So once you will be knowing that how you people can try to solve this type of questions, then it will become very beneficial and you can try to find it out. So here you will have a statement number 1, statement number 2. Akshay, can you tell me the answer with respect to this? Which is going to be valid, which is going to be invalid? Okay. This thing you have to solve. can you tell me that you are getting it or you are not getting at all? If you will tell me that you are getting it or you are not getting at all, then I can, make you to understand something like that. Otherwise, how I will make you to understand, something like that. Okay. Okay, so first I will try to tell you ki what type of questions we can try to find it out with respect to this type of things. Okay, so let's go and let's try to understand with respect to this. Acha, if you know the normal inference rule, if I will convert this normal inference rule like this, P or Q, negation of P and Q, and then that will implies R, and then this negation of R, that will implies P. So can you solve? Suppose if the quantifier wala question was not here, and if a question is like that normal inference rule, can you solve this question? First of all, let me tell you ki what kind of questions this type of are. Okay. For example, see, this type of equations are basically what kind of equations? Suppose if I will give my first statement, all students in the class, all students in the class will go to IIT. Okay. Now, this is first statement. This is the premises. So let me teach a little bit so that you people does not have any kind of problem with respect to this type of question. Suppose if I will say that ki all students in the class will go to IIT. This is my first premises. Suppose if I am teaching in a class and I have given a statement, all the students in this class will go to IIT. Second premises, some students in the class are not solving questions. Okay. Suppose, okay, just forget about logic. You just try to understand these two type of statements. So all students in this class will go to IIT. Okay. This is my first statement. Second statement, some student, and first statement, it is true. All the students in this class will go to IIT. This is true. Because we always take premises as a true. Everybody knows about it. We always take the premises as a true. And some students in this class are not solving the question. So this statement is also true. Can I say that all the students will go to IIT? Okay, all the students will go to IIT and some students are not solving the booklet. Matlab the bigger circle is going into the IIT. So this some students who are not solving the booklet questions will also go to the IIT. If the first and second are true, we can say that some students who are not solving the booklet questions will also go to the IIT. So how we can try to write it down? For all the students in this class will go to IIT. This is my first premises. And some students in this class are not solving the questions. So if I will say that those students who are not solving the questions will also go to IIT. Yes. So this question is something like this. This question is something like that, where this one will be true for all elements. This one will be true for all the elements, while this one will be true for some elements. Okay, for some elements. For example, here. So let's consider there are 10 students into that. So out of 10 students, the first statement will be true for all the 10 students. While this one, some students, let's consider it will be true for 5th student, or let's consider it is true for the 6th student. So this one will be applicable to that 5th or 6th student. This statement is not applicable for all the students. This student is applicable for only some students. You understood what I'm trying to tell you here? Please let me know that. Clear? Okay, so in that manner we can try to find it out. Okay, so how we people can try to solve this question? You just try to understand. Okay, you just try to understand. See the first statement. What the first statement says that ki this is true. So we can say that ki C of A will be IIT of A, where this A it should be equals to all the 10 students. Second student, C of A and negation of Q of A, where this A is only for the fifth student who is not solving the question. Now, according to simplification, we can take C of A outside, and then this one we will write C of A will become IIT of A. Okay. Then according to the modus ponens, I will get IIT of A. Now, this is for all, while this C of A, it is only for the fifth student. So, if okay, now what will happen? This C of A, it says that it is only for the fifth element. C of A will implies IIT of A. When you will try to match it, you will get answer of IIT of A, and this is for all elements or only for fifth element? This is only for fifth element. So here you will get 8 is equals to 5. Now this is negation of Q of A and IIT of A. So according to conjunction negation of Q of A and IIT of A, so here we can say that your statement will become true. Understood? Actually, you can ask the doubt here only, okay? Or you can write into the comment box, I will reply. Clear this question? So this means, it means that it should be true for all the elements. This means that it should be for some element. This is true for all the elements. This is true for all the elements. While this one is for only some elements. So this is for all, this is for all, this is for all. While this one is basically for some element. So you have to use, when you are using, see, when you will try to combine for all with some, answer you will get as a sum. All, you will get answer as a all. Some, there is no guarantee that you will get the same sum. It might be different sum. So now you can use the inference rule here and you can try to find it out, the questions which is related to that. I hope you got the idea regarding it, how we can try to solve with respect to this type of questions. Understood everyone? Clear? So that's how we people can try to solve the questions which has been related to that. Okay, let me try to solve this question here. I'll create a copy of this so that when I will share these things, you people will also have. Okay, now let's see the first question, or second question. Now you'll see the, take the first one, P of X or Q of X. So here it will become P of A or Q of A, where this A is for all, right? And then after that you will have a negation of P of A. So this is for sum. I hope you people are getting what is the meaning of a sum. Let me try to tell you, suppose if this is true. If this is true, so can we say that this will be true for all the elements in the domain? Yes, this will be true for all the elements in the domain. So if you will try to combine it, P of A or Q of A, this rule, disjunctive syllogism, you will get answer as a Q of A. And then what it will become? It will be for sum. After that here, you will get this one. This you can write it down Q of A or R of A. And this A is also for all. So negation of Q of A or R of A, this is also for all. When you will try to combine it, you will get answer as the R of A. And again this one will become sum. Because when you will try to combine, right? When you will try to combine all and sum, you will get sum. So here you will get R of A. Now this one you can write it down. S of A, that will implies negation of R of A, and this is for all. You take the contrapositive of this. If you take a contrapositive of this, you will get R of A, that will implies negation of S of A. So you write it down here. R of A, that will implies negation of S of A. So this is for all. So according to modus ponens, left side will match. You will get right side as the answer. So S of A. So this is for all or for some. So this is for some. So from there you can write it down. There exists of x, negation of s of x. So we can say that in this statement it is going to be what? It is going to be valid. Okay, that you can do as a homework. Understood everyone what I am trying to tell you here and how you people can try to solve it? Clear? Clear, right everyone? Clear? Okay. So that's it for the day, and we will try to solve the questions which will be related to that. Okay. Okay. So that's it for the day, and have a great day to all of you. So I hope I have taken a different type of questions and I have given to you so that you people can try to solve it. Okay. Chalo. Have a great day and thank you so much for listening. Great day to all of you. Bye bye.